Hello, ladies and gentlemen. We are going to go ahead and jump into the additional work problems worksheet. These are all going to be about work. Excuse me. As you can see, um, these are going to be problems doing work is equal to force time distance, and it's going to give you all the different formulas. Work is equal to force time distance, or distance is equal to work divided by force, and then finally we're going to find force is going to be equal to work divided by distance. So it's going to give you a way to practice uh, all three things, depending on what is given in the problem. So if you're given force and distance and you need work, you know you're going to use this one. If you're given work and force and you need distance, you know that you are going to use this one. So this is what this is all about. Okay, we're going to take the work is equal to force divided times distance formula. We're going to rearrange it to solve for what the problem is asking for. Easy stuff. I'm going to try to start doing it over here on the side. If it gets too much, I'm going to shift to an additional worksheet over here so I can work out some problems for you. All right, number one, you must exert a force of 4.5 newtons on a book to slide it across the table. If you do 2.7 joules of work in the process, how far have you moved the book? What are they asking for? All right, how far? That is a distance. So distance is equal to work divided by force. How did we get that? Well, the original formula, work is equal to force times distance. We don't know the distance. We're trying to solve for distance. So how do we do that? Divide both sides by force. And we get distance is equal to work divided by force. That's how we got it right there. So that's what we're going to use. So our work is 2.7. Our force is 4.5. 2.7 divided by 4.5 will get us 0.60 meters. Number two, same thing. Catcher picks up a baseball from the ground. The unbalanced force from the ball is 7.25 times 10 to the negative second, and 4.35 times 10 to the negative second joules of work is done. How far does the catcher lift the ball? How far? Distance. That's what they want right there. Same formula. Distance is equal to work divided by force. Okay? Yes, it's a lot of numbers to be okay. 7.25 times 10 to the negative second divided by, that's our force. I'm sorry, I did that backwards. Hang on. Shifts. I do not know how to erase still. All right. There it goes. All right. Sorry. Our work goes first. So our work is 4.35 times 10 to the negative second divided by our force, which is newtons, 7.25 times 10 to the negative second. You divide those two numbers and you're going to get 0.600 meters. That's our distance. That's how far he lifted the ball. Number three, same thing. The smallest bird is a Cuban bee hummingbird, which has a mass of only 1.7 grams. If this bird did a 8.8 times 10 to the negative 4 joules of work by exerting an upward force of 3.4 times 10 to the negative force newtons, how far did it fly? All right, that's all it's asking for is a distance, right? How far did it fly? Same thing. Distance is equal to work divided by force. So we need our work, which is 8.8 times 10 to the negative 4 joules divided by our force, which is 3.4 times 10 to the negative 4 newtons. That is going to equal 2.6 meters. That is our distance, and this is what we are looking for. All right, as you can see right here, we are probably going to be solving problems for force. They're going to give us, we're going to be solving problems for force. They're going to give us work, they're going to give us distance, and they want force. So let's do that. The world's most powerful tugboats are built in Finland. One of these boats can do 9.8 times 10 to the 7th joules of work through a distance of 35 meters. What is the force exerted by the tugboat? It's exactly what they want right there. So force is equal to work divided by distance. So our work, which is in joules, that's how we know it's work, is 9.8 times 10 to the 7th joules divided by distance, 35, and that is going to get us 2.8 times 10 to the negative, 2.8 times 10 to the 6 newtons. And that is our force. It is just simply dividing on your calculator. All right, find the right formula, what you did, put the numbers in, can't be wrong. Number 5, the child pulls up a sled on a snow-covered hill. In the process, the child does 405 joules of work. They give you work. If she walks a distance of 15 meters up the hill, how large a force does she exert on the sled? They want force. Force is equal to work divided by distance. Our work, 405. Our distance, 15, which gives us a force of 27 newtons. Feel good? I hope so, because I can't answer your questions. Number 6, one of the most powerful forklifts was built in Sweden in 1991. The lift is capable of lifting a 9.0 times 10 to the 4 kilogram mass of distance of 2 meters above the ground. If the work done by the forklift on the mass is 1.8 times 10 to the 6 joules, what is the force? Same thing. Force is equal to work divided by distance. So we find our work. Our work is in joules, 1.8 times 10 to the 6. Find our distance, all right? Our distance is going to be 2, which gives us a force of 9.0 times 10 to the 5th newtons. Just plugging it in, doing it on the calculator. Easy stuff. All right, going all the way down, number 7 here, okay? Number 7, this is our plain old work is equal to force times distance right here, all right? Probably going to do that right there. After the house, number 7, in the sample problem has been set on a truck bed, the truck accelerates until it reaches a constant speed. If the force required to move the house horizontally, a distance of 75.5 meters is 3,150 newtons, how much work has been done? All right, what is it? Work is equal to force times distance. What's our force? It's in newtons, 3,150, distance, 75.5, which gives us a work, of 2.38 times 10 to the 5th. If you wanted to do that without scientific notation, it's just probably going to be 238,000. Okay? We had to get it down to significant digits. Number 8, the largest passenger ship still in service is the SS Norway, which has a mass of 7.6 times 10 to the 7 kilograms. The force required to accelerate the SS Norway from rest to its top cruising speed of 33 kilometers per hour is 1.6 times 10 to the 6 newtons. Assuming that this acceleration takes place over a distance of 2 kilometers, how much work must be done on the ship during this period? All right. So all we need is work. It's the same formula, force times distance. So you have to weed through all these numbers and find your force and find your distance, and you'll be fine. That's all we need. So what is our force? All right. Our force is newtons, 1.6 times 10 to the 6. Here's the tricky part. What's our distance? It's 2 kilometers. What is distance measured in? Meters. You got to change 2 kilometers to meters. And 2 kilometers is equal to 2,000 meters. All right. Now we're just going to multiply those two numbers together. 1.6 times 10 to the 6 times 2,000 is 3.2 times 10 to the 9th. That's a 9. That is going to be our work. All right, if you don't want to do that scientific notation, just move that decimal point right there 9 spots to the right, and that'll be your answer. It's going to be like 3.2 million or 32 million or something like that. Maybe more, maybe 320 million. It's going to be a big number. Okay. Number 9. Suppose an adult blue whale is stranded on the beach. The whale, which lies parallel to the shore, is 15 meters distance from water deep enough for it to swim away. A group of people line up along the side of the whale to push it back into the ocean. Wow, that's a lot of people. If the whale's weight is 1.5 times 10 to the 6 newtons, and the force of friction that must be overcome by the people is 2.5 times the whale's weight, how much work must people do on the whale in order to return to the ocean? Wow. A lot of numbers in there. All right? A lot of numbers. The key thing here is you have to multiply in the force of the friction. Okay? Because that's also a force. Okay? So it's still weight is equal to force times distance. But now your forces are 1.5 times 10 to the 6th, and you have a 0.25 friction force. All right, you're going to multiply all that by the distance, which is 15 meters. All right, so the key here is to get our two forces. There's a force, and there's a force. They all have to be included into the equation. All right, 1.5 times 10 to the 6 times 0.25 times 15. As you can see, I'm going to keep looking away. I already have all these worked out. It's 5.6 times 10 to the 6. All right, again, if you want to put that out in not scientific notation, move your decimal point 6 places to the right. Number 10, these are all mixed. This is your opportunity, our opportunity as we go through to find out which formula we are going to use out of those 3 formulas that we have been practicing. So let's do that first. All right, so first thing we're going to do as we go through each one of these is find out which formula we need. We're going to write it down. A mover is loading a 2,586 kilogram crate of hammers onto a truck. The upward force on the crate is 2,470 newtons, and 3,650 joules of work are required to raise the crate from the pavement of the truck bed. How far is the crate lifted? Well, what do they want? They want distance. So we know that distance is equal to work divided by force. What do you know? That's the 2 numbers they gave us. Work goes on top. Here's work right here because it's in joules. 3,650 joules divided by your force, newtons, 2,470. And our distance is going to be equal to 1.48 meters. All right, find the right formula, plug it in, can't be wrong. Number 11. The mover in problem number 10 uses a ramp, which makes the truck task easier, requiring a small force to raise the crate to the truck bed. This force must be exerted over a greater distance, so the work done should be the same. In reality, because of the frictional force between the crate and the ramp, the work required is greater than that needed to lift the crate directly onto the truck. The mover does 4,367 joules of work sliding the crate up the ramp. The force the mover exerts the crate is 1,302 newtons. How long is the ramp? What do they want? They want a distance. So we need a work and the force. Lo and behold, that's the 2 numbers they gave us. Work goes on top. We know this is it because it has joules. 4,365 joules over force, 1,302 newtons. And our distance then will be 3.353 meters. 3.353 meters. Significant digits. Number 12. A popular endangered circus act is a human cannonball, in which a person is shot from a cannon. Suppose the cannon has a barrel that is 3.05 meters long, 1.67 times 10 to the 4th joules of work is done to accelerate the acrobat. What is the force exerted by the cannon on the acrobat? What do they want? They want that guy right there. We know that force is equal to work divided by distance. That's the 2 numbers they gave us. Work goes on top. Here it is in joules. 1.67 times 10 to the 4th divided by distance, 3.05 meters. which gives us the force of